Dun, dun, dun. I'll just put it later. Okay, transistors are up next. So we finally get to talk about transistors. The reading for this week is some of it is in the Art of Electronics textbook. I didn't get you guys. I didn't put that in there as a required text just for and giggles. So transistors, it has a nice discussion of these. They're important elements that are the primary elements in integrated circuits. So integrated circuits are, I guess, something you would hear them commonly referred to as boards. They're boards that have the circuits all integrated into the boards. So a lot of details in that we are not going to go into. But the mechatronics engineer will typically use integrated circuits rather than design them. So they're going to use them rather than design them. But may need to understand these elements at a basic level. So it's best if you have an idea of how a transistor works. You can use them in circuits, and I actually have some seniors who are going to use a transistor in a very specialized way in a circuit. You can use them for several different things. They're great. I would say that most of the time we're going to buy integrated circuits and not design them. So we'll just buy something off the shelf that has a bunch of integrated circuits in it, and we're going to just use its input-output properties. And the quintessential example of such a component is an op-amp, and we are going to talk about those hopefully today as a plan. So anyways, we'll get there. So transistors are primarily used for either power amplification or switching. Okay? As a power amplifier, a power source can be used to amplify the input's voltage or current or both. This is different than a passive transformer, which adds no power. Right? So an amplifier is going to be something that you supply external power to, and then you use a small voltage or current to essentially specify how much that power amplifier should supply. And that sort of amplification is very useful, and we're going to talk a little bit more about that when we talk about op-amps in a moment. So it's a useful thing. And switching is the other one. Switching is probably the only thing you will probably encounter as a potential use for a transistor as far as your own designs go. You can use it for switching. And the Art of Electronics, the reason I'm having you read this section is that it has some good discussions of that. And I think it's really good stuff. I'm not going to be testing in-depth knowledge on transistor circuit design in this class, but I think that's a useful thing for you to be aware that you can use. So, transistors are also used as electronic switches. This is easier to understand with a short introduction to the operating principles of a transistor. Okay, so that's what we're going to do. There are typically 3 terminals on a transistor: the base, the collector, and the emitter. Okay, it's constructed with doped. Sorry, I lost my spot there. It's constructed with doped semiconductor material. 2 doping configurations are used. The figure here shows an NPN, and the other is PNP and reverses the polarity. So I'll label these. See here. There we go. This is the base, B. This is the collector, terminal, C. And this is the emitter terminal, E. And current we can think of as flowing this, like this, and like this. This is an NPN, and then the PNP is just reversed polarity. Under certain operating conditions, we can say that the collector current, IC, is equal to beta, which is a constant typically around 100, times IB, which is the base current. Okay, where beta is typically around 100. If we connect the emitter to ground, so let's just sort of do a little thought experiment here about one potential way we could use this. Okay, so if we connect the emitter to ground, which is a common way to connect it, but certainly not the only way to do it, we can see that if IB, the base current, is 0, then IC has to be 0 according to this relationship. So we can switch the larger collector current. So the collector current is like 100 times what the base current is, right? So we can switch the collector current on or off by making the base current large or small. Okay? So if we make the base current really small, then, or to 0, it switches the collector off. If we increase it, it turns the collector on and flows a lot more current than we're flowing through the base. So that's one of the ways we can use this in a circuit to do switching, and also power amplification as well. So the textbook gets into a lot more details on that, and I would recommend reading it. It's one of those things that I think is really great to learn about, but I don't think it's on the critical path for us in this course to learn about those details. So if you find an interest in it, then I really highly recommend you explore it a little bit further. Okay, so